Welcome back on a Monday afternoon. It's quite quiet these days. The repair business is very low, so on my side I'm seeing it as an opportunity to move further with our lessons. Let's go back in time 17 years ago, 16 years ago, 2006, 2005. I was building things, funny things, some toys, You see that helicopter which I showed you on one of my videos. So today, let's design a linear power supply, subwoofers and the other old radios. During those days they were using linear power supply. Let's see how it can be. Let's play and design a linear power supply. So what do you want? Already we have our transformer. You can see that's the big transformer. That's the high voltage, the input and the output. We have many wires. What else do we want? We need a rectifier. I didn't do any research, so I just picking random components. Let's check out the rectifier. That's the switching. Let's check out the rectifier bridge from this switching power supply. Let's do it. Let's see how hard it can be to build a working linear power supply. That's what I was doing during my days, So let's see how hard it can be. I need to take out this rectifier bridge. Let's check out the rectifier bridge, Yeah, these days it's very quiet, so we can afford to play because the rate of business is very, very low. That's our rectifier. What else do we want? I need some filters, I need some filters. I think we can use just one. That's our filter. What else do we want? What about a regulator? Can I get one? Let's do it, That must be fun, What do we have on our boards? Switch, probably we need one. What else do we want? Do we really need an LED? Maybe. I think we are only left with a few things to start, What is this? 7805 linear regulator. Okay, let's take off this regulator quickly. Let's take it out completely. Let's design our linear power supply and see if we can able to do it properly, I'm getting old, so some of the things I will forget, but let's try. What do we want here? We need some cables, Cables. I need one cable. I need to do something fun here. Something fun. What about this? Yes, that's the cable. That's the cable. So let's do it. Let's do it and see if that can if I still remember what I was doing 16 years ago, you know. Let's do it. That's the input of our transformer. Let's sort out the input first, you know. Let's sort out our input first. Okay. Should I stick this with the glue? Let's just stick, you know, with the glue. Okay. Let's leave this like this. What I want to do next, maybe we need an insulation tape. If I have one, I do have one, because I don't want to be electrified, you know. Let's see if we can able to do, if I'm able to do what I was doing 16 years ago. Let us see. Okay. Let's plug this one. Let's check some voltage on the output. What is written on this transformer? 13, 0, that's the ground, and 13. So we have two outputs here. This one is giving 13.5 plus 13.5. The blue is 27 volts, and the yellow is said 11 volts. Okay, so let's check for 11 volts AC. Let's check if we do have 11 volts there. 10, 11 volts, good. Let's go on the blue one. What do we have on the blue? (26.9, 27). That's good. So our transformer is working. Let's unplug it. Okay. What's next? Everything here should be quick, you know. Let's take out this. Let's go with lower voltage. We don't want high voltage here. Let's eliminate that 27 volts, you know. I'll insulate these wires for 27 volts. Let's insulate this. Because we don't want to use this 27 volts. Let's go for lower voltages. That should be okay. So what I want to do next, let's connect our rectifier bridge. Let's come up with the rectifier, you know. That should be quick, very quick. Let's connect our rectifier. Rectifier. Let's do it. Let's do this. That's the input AC, another AC. AC. Okay, before I can go further, I want to connect back my cable and check on the output. Connected output. What do we have on the output? We have 9 volts. Okay, let's continue. 9 volts. So our rectifier bridge is inputting 11 volts and outputting 9 volts DC. Okay, I need some wires, you know, some wires. Let's fix the output of the rectifier. Output minus and plus. I'll tell you after why I was doing this. After building this linear power supply, I will explain. I'll explain few things. Just wait, you know, because I know many people, they really want to know why I was doing this. I'll explain after, but just wait. Okay, minus. Let's fix the minus and plus, you know. Our rectifier bridge is okay. Let's move on. After the rectifier, what do we have? After the rectifier, we do have our capacitor, you know. Let's put our capacitor. Let's put our capacitor in place. That's the capacitor to filter the voltage from the rectifier. Let's put our capacitor. Let's do it. What we can do? There's nothing we can do. Let's fix the minus thing, you know. Minus and plus of the capacitor. Okay, what I want to do next, okay, 25 volts. I think that's too big. Can you find a lower value capacitor here? I think 16 volts should be okay. 25 volts is too much, because already I know what's going on the rectifier, what voltage we have on the rectifier. Let's change this capacitor. I think it's too big. Let's put a lower value. We don't really need 25 volts, you know. Let's put the minus. Let's connect our capacitor, you know. That's my capacitor. I'm anxious, you know, to see if that will work. I can't wait to experiment this, you know. So we do have our L7805 regulator. That's a real linear regulator. Let's check if our regulator is good. Yeah, seems to be good. So okay, so I need 3 more wires to fix the regulator, no? The regulator thing. Let's do it. Let's fix the regulator thing. Of course we are playing, but this video should not be too long, you know, because if I'm going to make this video very long, you get bored, you know. I don't want you to get bored, so let's do it. We are just doing random things here. I didn't do any research. No, I didn't do any research. I'm not reading any notes here, but I just want to see if I can recall what I was doing 16 years back, you know. I'm doing this video to test my memory. Sometimes it's good to test, to go back in time few years ago and try to recall how we used to do things, you know. So let's do it. Let's do it and see if that can give us a working linear power supply. Input, let's call it white. That's the input of the regulator. Okay, and yeah, let's fix the ground thing, and we need one more wire. Let's look for a different color, you know. Red should be okay. Let's fix the output. That's the output of the regulator. Good. So the input on the plus, let's connect our input on the plus. Okay, and our output on the minus of the capacitor. Okay, that's the output. Should we test? But I need to do more things after. Let's test. Let's test the output DC plus minus. Check on the test meter, 5 volts. Our regulator is working. We now have 5 volts. That's good. Let's disconnect. Let's do more things here. Our regulator is working. So what I want to do more, we need one more wire. Let's cut this red wire, it's too big. Let's do something fun, you know. Then there's nothing wrong to play. Nothing wrong to play. So I need one more wire from the minus, you know. Okay, and plus what I want to do more, let's do it as fun as you can, you know. Let's connect. We're just building things on air here, no schematics. So let's see. Let's put a switch along the circuit. Let's put our switch. Okay. Let's go on the output of the switch. What I want to do on the output, I want to put another. Okay, let's do it, you know. That's the output. Is this a working LED or not? I just pick it. I don't even know whether this thing works or not, but we can try. We can test. Maybe I'm on the wrong direction. Which one is the minus and plus here? It's working. So if this is a plus, if this is plus, it's not a big deal. Let's connect it in serial mode with our switch, you know. Okay. Okay. After that, what do we want here on the output? On the output, I need any cable. I need any cable, you know. I need any cable. That's the cable of our phone charger. How can I do it? Let's destroy this cable. This is a new cable, but it's our cable. So let's destroy it completely. Let's do some magic here, just to see if our linear power supply is working. Let's destroy this cable. Because we need to see if our linear power supply is working. So what do we need here? What do you want actually? Oh, we want to fix few things here. Let's do it. We do have four wires on our cable. Plus, we do have a plus and minus and some data pins, you know. So what I want to do, I want to connect this to the minus, and then after we need to connect our cable here. But how do I know which one is a plus, which one is minus? Any idea? Any idea? How am I going to know which one is plus and which one is minus, you know? Okay. I think I just seen the configuration. So let's do it. Minus and plus. That's our minus. Yeah, we were about to finish. The minus is fixed. Let's come with a wire on the plus. Let's come with a wire on the plus. What I shall do on the plus, we do have four wires which are going to the charger, you know. So on those four wires, one is plus, one is minus, and we do have two data pins. So I just short data pins to the plus, and I'll connect on the output of the regulator, you know. Yeah, that's what I was doing long ago. I used to build funny things, but let's do it again, you know. Nothing bad. just to do old memories, you know. Okay, so let's fix the last connection on the plus. Let's connect our plus here to the output of our LED. Okay, yeah, I think we are ready to test. Let's take other things out. So what I've done here, I just finished building my linear power supply. That's the transformer. You can see red wires on the input. That's around 230, 240 volts. On the output, I eliminate these two blue wires, which are 27 volts, and concentrate on this lower voltage, which is around 11 volts. From this, we have our rectifier bridge. That's our rectifier bridge, which I took it from Boards for Space. That's a switching from a switching power supply, which is changing from AC to DC. After that, that's our capacitor, 16 volts, 1000 micro, to filter the voltage from the rectifier. And then I connect my regulator. That's a L7805, because on the output we need stable voltage. So our regulator is there to ensure we do have stable voltage on the output. And what I did further on the output, I connect the switch. This switch will be able to turn 5 volts on and off, on and off, on and off. And on the output, we do have that's our cell phone charger. So let's plug in and see if it's working. Just fun, you know. Wow. Okay, nothing explodes. Okay. Where should I check now? Let's check voltage after the switch, you know, before. Five volts after 5 volts after the LED 2.9, five volts. Okay, let's do this. Let's do some few modification here. Let's take off the LED. We don't need it. Let's just connect our switch and let's just connect our switch like this. Again, plug in. Let's check some voltage on the output, you know. Minus 5 volts on the output. 5 volts. Okay. Input 5 volts, output 0. So now our switch is off. Let's turn on the switch on. Let's check on the output. Now 5 volts. If I'm to check here, we do have 5 volts. Let's plug in phone and test. Let's see if our phone is charging. Check. Smart, that's an Hisense phone. Our phone is charging. Okay. Maybe the battery of this phone is too low, but let's just wait. Yeah, the battery of this phone seems to be too low. Let me check with a different phone. Check the charging sign. It's charging. So that's what I was doing. Our phone is charging. You can see. You can see the charging sign. It's charging. So let's leave our phone charging. Let's go on the screen. 1 second. Let me go on the screen. I need a mouse. Let's go on the screen and explain few things here. Let's explain few things new. So what I've done here, nothing complicated. That's our AC 230 volts here, and after the AC we do have our transformer. I don't want complicated things, so I'll just draw a T, and here let's concentrate with 11 volts on the outputs. 11 volts. After that I put a rectifier bridge. That's AC. On the output we have plus and minus. Here what we have on the output, we're having 11 volts AC. On the output here there was 9 volts DC. After that I put my regulator, let's call it R, you know. That's our regulator. In this case it was 7805. L7805 regulator. After the regulator I put a switch, you know. That's our switch. Nothing complicated, our switch. And a resistor here to lower the voltage going to our charger. After that we come with our 5 volts DC charger. That's plus, that's minus. Nothing complicated. So that's how things works. So what the transformer is doing, is stepping down. You know, this kind of transformer is stepping down AC voltage. You can see here we do have AC high voltage, and here on the output there was 27 and 11 volts. This transformer is stepping down our AC voltage, and after that we have the rectifier changing from AC to DC. And in order to have a smooth voltage on the output, we use 7805 regulator to smooth our voltage on the output. And we have our switch just to turn on and off our 5 volts on the output. That's how things goes on a linear power supply. That's a linear power supply. Linear power supply. So yeah, that's what I was doing long ago. You can see our phone is charging fine, no issues. So I'll stop this video now, and yeah, we'll try to do some more funny things. You know, we just built our working linear power supply, and nothing is getting hot. All the components, they are cold here. Even our regulator is getting just warm. I think can be sticked on heat sink, but this was just a discovery video, just to go back in time and see if I can recall what I was doing 16 years ago. So like, subscribe, and follow our YouTube channel. See you on the next one. Bye.